coding questions being part of the other topics. For example, there could be a question based on number series or alphabetic series, or there could be a question based on some other puzzle, for example, where one of the hints could be given as part of a coding question. In today's session, we're going to look at a few questions, and using them as an excuse, we will start uh, looking at the various underlying concepts that can help us solve coding questions. Yes, the entire class is going to be driven by questions because that I believe is one of the easiest ways to learn. Let us get started with a few questions and how they start working. So here we have a question. When somebody took the word breakthrough and wrote it in a different way. In every coding question, they will take something as the input or the initial word and write it as something. Let us use the word input for this, and this will be the output. So our task in a coding or decoding question is to first understand how did the input become the output. Now, if I keep looking at it, we might not get any ideas. So in a coding decoding question, the first check that we need to do is, are the letters same or different? Are they same or different letters? If I look at the word breakthrough here, there's a OU here, OUGH, OUGH, BREAK. It looks like the letters are same. Usually the first check that you need to make, because the letters are same, we have one type of model and one type of technique. The letters are different, we have a different type of technique. Now in this question, this is based on same letters. If the letters are same, we call this a rearrangement based problem. Rearrangement is a word that is used. The letters, the thing is coded by rearranging the various letters. Now, how did they rearrange? Let us now give position numbers. B is in the first position, R is in the second position, E is in the third position, A is in the fourth, K in the fifth, T is sixth, seventh, eighth, ninth, 10th, 11th, and 12th. Now, breakthrough B, which is in the first position, has now come to, let me put the number, say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So B, which was originally in the first position, now came to the seventh position. R, which is in the second position, came to the eighth position. Now what about E and A? 3 is in the first position, 4 is in the second position. K, which was in the fifth position earlier, has now moved on to the 11th position. Now we need to keep doing this till the time we notice that there is some pattern. One pattern that I noticed is groups of 2 letters at a time are moving. B and R became one group and they moved. E and A moved together. Similarly, K and T moved together, they went to the end. So whatever movements are happening, we notice that they are happening with 2 consecutive letters at a time. So while we have 12 letters, we notice that 2 of them at a time are moving. Now let's look at the pattern a little more thoroughly. Now the H here, which is in the 7th position, went to the 5th. The one in the 8th position went to the 6th position, that is R. Now the one in the 9th position, O, went to the 3rd position, and the one in the 10th position went to the 4th. Okay. The G and H, which are in the 11th and the 12th positions, respectively went to the 9th and 10th positions. This is what happened. Now, do I still understand the pattern? The first 2 positions, became went into the second half of the word. Seventh and eighth in a 12-letter word, the first half is 1 to 6, second half is 7 to 8. The letters which are in the beginning of the first half went into the beginning of the second half. What happened the next letters, the letters E and A, because B and R have been removed, these have moved forward. We can keep thinking about a story like this. But in this question, let us check out how many letters do we have in this word distribution. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In a 12-letter word, the transformation, whatever happens, will be exactly the same as what happened here. So just put in the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, 12. The final thing has to start with the seventh letter. The seventh letter, if I follow this pattern correctly, the 1 and 2 should go into the 7th and 8th positions. Okay. So I have, if I say this is the second half of the coded one, and this is the first half, the second half should start with D and I. Then we have the third and fourth letters should come to the first and second places. So the words will start with ST. The fifth and sixth letters should go to the last, so it will end with RI. The seventh and eighth letters will go to fifth and sixth places. So this here would be PU. Next, the ninth and tenth letters go to third and fourth positions. The ninth and tenth are T and I, which are going to the two positions here. Now the 11th and 12th letters are going to the ninth and 10th places. So this would be O here, N here. So this should be the final output. S T T I V U D I O N R I. This is one of the models, which is what we call the rearrangement model. What happens in a rearrangement model? We take the same letters and we change the positions based on some logic. Many times in the exam, you don't need the actual logic. You just need to know what happened in the example word and replicate. Now let us check out one more model. In certain code language, there is a word standing which is written as something else. As I mentioned, so the first check is to find out whether the letters are same, standing, and the letters are same. S, A, N, D, I, G. The letters are the same. So this would again be a rearrangement problem because letters are same. What should we do now? We need to understand how the letters are transformed, and we need to do exactly the same thing in the target word. So let us look at 1, 2, 4, 5, 6, 7, and 8. Compared to the previous question, there's one complexity here. The complexity here is that some letter like N is repeated. So when I see this N, which N is it? Is it the N coming place, or is it the N coming from the seventh place? We don't know. Compared to the previous one, I'll also tell you a slightly easier way of writing down. This S is in the first position. So here let us write 1, saying that this S came from the first position. Now T is in the second position. Let's write it here. Now the third position is A, which came to this place here. Then we have an N, but I don't know how to write it. Then we have a D. The D, which is in the fifth position, went here. Then we have I, which is in the sixth position. Then we have N, which is in the seventh position, and G in the eighth position. So based on the series I see here, this should be 4 and this should be 7. So what did they do? This time around the logic is easy to notice. They divided the word into two parts. They reversed the first part and they reversed the second part. So I need to take this word, divide two parts, reverse the first part and reverse the second part. So it would be DORP, which is the reversing of the first part, and SCU, which is the reversing of the second part. So this should be our answer. Yeah, it happened that the first option is right for two consecutive questions. The exam, you don't have any such patterns, so don't bank on that. So what happened here? Here we have understood how the division happened, and luckily this time around we could notice a pattern. If you notice a pattern, it will sometimes be faster, but don't waste a lot of time trying to notice a pattern. Sometimes you can just go ahead and use the algorithm. And let me remind you again, this is what we call the rearrangement model, where the letters are the same, only their sequence is changing. Here we have one more. And let me tell you again, we are still looking at the same rearrangement. In the exam, this would possibly be the first and the most important step, knowing what kind of model. Now we have one more issue here. In the previous question, we had only one letter N repeating. Here we have more repetitions. Here we have N repeating, I also repeating. When you have repeating letters, sometimes it might be slightly more difficult to notice a pattern. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So we have an 11 letter word. So this G is the first letter, this is second letter, third letter, fourth. I don't know where the fifth one went because this I could be either be the fifth one or the ninth one, so I will not even write it. Same with the N. This A is for sure the seventh letter originally. The T was 8, O was ninth. So I was ninth, so I'm not writing it. O was the 10th one. And again I have an I. So what happened here? There are two I's and two N's that we could not write well. Everything else has been taken care of. Now, if the final one is also 11 letter word, our life is easy. So we have 3 here, 6, 9, 10 and 11. Because both are 11 letter words, it's usually much easier for you to go ahead and do something like this. So how do I do it? The first letter, whatever is in the word, came to the third place. So if I take a word here, notice the pattern that I'm using. I'm using three letters, three letters, three letters, and the last two letters. Three here, three here, three here, and two here. That is how I'm dividing the 11 letters for my convenience. Somebody else might divide it in blocks of 5 letters each, or whichever way it works for you. First letter should come to the third position. That is what happened. G. So E should come here for sure. The second letter should go then with third letter followed by second letter. So it will be T followed by S. The fourth letter, which is A, comes to the second position. So I will write A here. Now the first letter here is I. I happens to be either the one in the fifth position or it could be coming in from the ninth position. But if I look at the numbers closely, because this entire group is 1, 2, 3, 4, 4, there's a very high likelihood that this is coming from the fifth position and this I here could be coming in. So let us say the fifth letter, which is a B, comes here. B-A-E-T-S. So by this time we know that the first option is wrong. We know that the fourth option is wrong because we have completed the first 5 letters. This letter is N. The 11th letter is also N. So out of these two, one of them is the sixth letter, another is the 11th letter. But I do not know which one is the sixth one, which N is coming from sixth place, and which N is coming from the 11th place. So this letter here can either be L or it could even be D. So in this position, after a BAETS, it can be either L or it could be D. But what happened is, among the options, we have only LD as a L coming first and D coming later as a com. So we'll go ahead and accept that this happens to be one, and the next one is the 11th letter. We'll can sometimes adjust with it. Now look at the next one. After L, which is the sixth position, we need to look at the I, that is the letter in the seventh position, which will come and sit in the ninth place here. So I should come here. This time we notice that these things look correct. So we can go ahead and mark the second option. Yes, in the exam, sometimes we might be slightly concerned about the none of the above, but if you notice a pattern which is sufficiently strong, you can go ahead. If you want, you can persist with this till the time you get the answer. For example, here the 8th and ninth letters are H and S, so this should end with a H, and before that should come S, and that should be sufficient for us to mark the answer what we want. We actually end with S and then comes H here. Okay, now here we have a different kind of pattern. The first model that we looked at is the model where all the letters are the same between the original word and the coded word. What's the name we use for it? We said they are coming from a model of rearrangement. Now we are coming for what we call a replacement. Now Scotland is written as 1, 2, 3, 4, 5, 6, 7, 8. If I look at these words, do they have any relation to the letters there? No relation. So S, which is in the first position, here we got the numbers 1 to 3, 1 to 8. Now look at L. L is written as 1, 4, 3, 5. Now how did it become 1? We don't know. Lots is written as something. Dan is written as something. Son is written as something. One direct idea I got is when Scotland is written as 1, 2, 3, 4, 1 to 8, I think S is 1. When I looked at S is 1 and then I came to this zone, I realized that S is not 1, because if S is 1, then L cannot be 1. This is a question which is based on set concept. This is one of the models in coding. Remember that this is the set model or the overlap model. Excuse me. In an overlap model, you should always start with the smaller ones. SON is written as 4, 5, 8. It means that one of these letters is 4, one of these is 5, and one of these is 8, but we don't know which one is 4. But now look at one more word, Dan. Dan is written as 5, 3, 7. In the code here, 5 is present in both. But if I look at the original word, N is present in both. We look at this, okay, which letter is common in the original word and which letter is common in the word, and then we say N is being represented as 5. Now we have S and O being represented as 4 and 8, D and A as 3 and 7, but we don't know which one exactly is for what. Now look at LOTS. In LOTS, which is written as 8, 1, 4. We know that S and O together are 4 and 8. So if remove S, remove O, 4 and 8. But we do not know which one is 4, which one is 8. S or O is 4 or 8. We just know that much. But what it also told is L and T. One of them is 1, the other one is 2. Again, we don't know one, which one is 2. They need the code for C, so we are not going to spend too much time on trying to decide what is the code for L, for example. Now look at loan. LOAN is written as 1, 3, 5. What is L? L is either 1, but in this code, while we have letter L in the word, we have only 1 here, which means L should be equal to this 1. If 2 is also present in this word, I would have been confused. So L is equal to 1, T is equal to 2. We can cancel this out. Now we have similarly O and A. So we have the values of some of the letters here. How many do we have? Out of 8 letters that we originally wanted, we now have values for N, which is 5, L is 1, T is 2. That is for 3 letters we have direct values. S and D we know should be one of 4 or 8. So that would make it 5 letters, which still means that there are some letters for which we don't know the values. We know N is 5 here, for example, so we can cancel this if we want. Now, if we come back, we know that O should be either 4 or 8, only, out of which only 4 is present, so O is equal to 4 is one conclusion. As a result, we also know that A is equal to 3. Now look at Dan. In Dan, we say A is equal to 3, which leaves us with D is equal to 7. And if S and O, one of them is 4 and another is 8, and O is already 4, we'll also say S is equal to 8. The idea here is we are looking at them as sets. S, O, N are 3 different numbers. 4, 5, 8 are 3 different numbers. They are somewhat mapped to them, but initially when we see the question, we do know if I summarize it. The first step is you will not start with Scotland, you will start with the smallest one. Deciding. Third, cancel known values. If I just do these 2 steps continuously, the second and the third steps, you will eventually get values for whatever you want. Now, in this particular set, we have have thought